tolerances are listed in the specifications or documentation for that product. This design tolerance will typically be the primary tolerance limit for your shop. Once you've purchased a machine, the setup, tuning, and maintenance of that machine can impact how likely you are to be able to maintain the factory tolerance. Finally, it's important to be able to check the parts on the machine to the proper tolerance specifications. In order to verify the dimensions of a part, you need measuring tools that have a greater precision than the tolerance being evaluated. Once you understand the capabilities of your machine, you need to decide what tolerances you want to offer as a standard service. Manufacturing parts tolerances close to the limits of your machine's capabilities may result in a greater number of rejected parts, or may require more time support to verify that a part meets the customer specifications. Ultimately, you may want to charge more for maintaining higher tolerances. Once you decide what tolerances you want to offer to your customers, listing that information on a website or in a design guide will provide a quick and effective means to share your standard tolerance information with your customers. CAD designs.
गाइस ये मेरी कितने मिनट की 1 2 3 4 मिनट की एक ट्रेनिंग है। उसके बाद मेरे क्वेश्चन आंसर्स हैं, उसको मुझे पास करना पड़ेगा। ठीक है, तो देखते हैं कि वो क्वेश्चन आंसर मैं कर पाती हूँ या नहीं। ठीक है, मैं आपको दिखाऊंगी।
Represent the ideal geometry of a part. When that part is manufactured, the reality of machine physics and material properties will impact how closely the manufactured part matches the CAD design. Computer-aided machining software, or CAM software, translates the CAD design into instructions that can be sent to a CNC machine tool to control how that machine tool fabricates a part.
जल्दी जल्दी आ जाओ गाइस,
These
दिखाती
instructions
हूँ।
correspond
ये
to a list of movements
ट्रेनिंग करने
that
के
the
बाद एक
machine
टेस्ट
will be
होता है, वो
handed.
पास कर पाऊंगी या नहीं,
While
आपके
the
सामने दिखाती
surface
हूँ
of
मैं।
a physical object may form
प्लीज
continuous
करना तो
lines and
अच्छा है।
curves, information about expected tolerances of the part to be manufactured, it is up to the operator to understand how tool paths and feed rates may impact the tolerances of the final manufactured part. Speed and precision are frequently encompassed in manufacturing processes. Any movement requires acceleration, and accelerations generate force. These forces cause machines to deflect, which reduce the ability of a given machine to maintain its manufacturing tolerance. These deflections affect many types of machines, from 3D printers to large cutters to CNC mills. Any vibration in the machine, from motor energy to cutting forces during machining processes, will add to deflections. For subtractive processes like milling or turning, tool bits wear over time. CNC machines can compensate for tool wear up to a point as long as the tool bit is still effectively removing material. It is much more difficult for CNC equipment to compensate for uneven temperature changes of a part as it's manufactured. Heating from things like cutting forces or 3D printer nozzles can cause parts to expand and deform. Material may be removed or added in ways that violate dimension tolerances. For simple surfaces, geometric tolerances can sometimes be evaluated with the dial indicator. For example, that surface plate. This technique can prove difficult for more complex parts, so other methods should be considered. One of the most direct methods to verify the tolerance of a part is through the fabrication and use of a go gauge or a no-go gauge. The go or no-go gauge is designed to mate with a manufactured part. Any feature of the manufactured part that is outside of the specified tolerance zone will prevent mating with the gauge. The gauge must be fabricated more precisely than the part being evaluated. Typically, gauge tolerances will be 10% of the tolerance given to the manufactured part being evaluated. Another common method for verifying the geometry of the manufactured part is the use of a coordinate measuring machine. These ultra-high precision devices are mounted on a rigid base and have an articulated arm with a probe tip attached to the end. The probe tip can be moved around in space, and the location of the probe tip is recorded. The part needing to be measured is mounted on a rigid base near the coordinate measuring machine. The probe tip is moved around the surface of the part, and the coordinates of the probe tip are recorded. This setup places
सच में ट्रेनिंग चल रही है, झूठ नहीं बोल रही हूँ.
geometry of the part. Any point coordinate which is outside of the desired geometry, more than the tolerance specification allows, will cause the part to be rejected.
Guys, is a question time. दिखाती हूँ आपको. Why do cutting process and the 3D printer nozzle causes issues that are difficult for CNC equipment? Why do cutting causes issues that are difficult for CNC equipment to compensate for the use of subtractive process wear out tool bits because their precision are frequently in conflict. They generate uneven heat. 3D printer nozzles. Let's try this one. Correct. Oh my god. Which of these options translate the CAD design into instructions that control how a machine make a part? Composite aided manufacturing software, computationally affected machine software, computer aware manufacturing software, computer aided machine software. ये तो मुझे नहीं पता यार, गैस करूँ, गलत पाएगा ये वाला. नेक्स्ट, ये भी गलत. चलो सही हो गया. What is the relationship between speed and the precision in manufacturing? Lower precision leads to slower speed.